Hello and welcome to the good, the bad and the ugly of design systems. My name is Andrea Konechnikov. I'm a UI engineer with experience in both design and development, and I specialize in design systems. Currently I work as a design system lead at a company called Adverity. What are design systems? I define design systems as a set of design-related rules, as a system of instructions that can be reused across single or multiple products. And here are design system goals that we pursue normally, right? So it's user interface and user experience consistency, a common design language between engineers and designers, a development speed, and enforcing best practices such as accessibility and usability. At Adverity, design system being used in 3 different products by 30 or even more front-end engineers and a few designers and dozens of teams every single day. Every design system has different life cycles, and as it matures, it goes from analysis, where we actually discussing what needs to be added to the design system, through implementation, where we implement our components or our rules, to the maintenance, where we support and help teams to adopt the design system. And normally, the fun factor when working on each of those life cycles goes down over time. So in the beginning, it's normally an excitement and the mood is generally great. Then it goes to implementation, bugs start to flow in. So the mood kind of goes down, and then it's actually getting even worse. The amount of bugs only increases over time if you don't invest into the maintenance. So we are somewhere here in Adverity when I was joining them. So I started conducting interviews with different stakeholders and different users of the design system. I found out that there are a lot of issues, but most common things were mentioned where design system is a single source of failure, or there is no release process and every breaking change of a design system can take days to upgrade, or designs aren't always in sync with engineers and stuff like that. So how did it happen that a design system that should be a single source of truth for the whole organization suddenly became a single source of the failure? There are a few things that led to this. So first of all, we didn't have any types. So the whole design system code was written in 100% JavaScript. Then we had little to no component test. And CSS changes would lead to regressions in products, and we didn't know about those. And it was really, really hard to test. So why don't we write tests, right? Well, because we don't have time for that. Why? Because there is too much work and pressure. But why? Because we don't move fast enough. Why? Because changing software has become difficult and risky. And why is that? Because we don't write tests. So as you can see, it's a vicious circle, which is really, we had to break at some point. So why even invest in the test? First of all, of course, quality of the product. The next thing we can think about is the confidence of a change, right? So if any engineer is confident doing changes, we also inevitably gonna gain in speed of development. And that were our goals. So we started these testing strategies. So first of all, we thought, hey, what if we don't write tests at all and get some safety? So we started moving from JavaScript to TypeScript, because TypeScript helps us eliminate the whole set of bugs. We decided to plan as an epic so we could track our progress. And also we introduced these labels to our components in the style guide so we can see which components are already migrated. And engineers who use design system every single day, they could also understand, oh, okay, this is old component and I have to be careful. This one is a TypeScript component and I can rely on the types. So what we found out is that it was hard to dedicate time for this kind of maintenance work. So we created a rule. If you're refactoring a JavaScript component, you have to convert it to TypeScript first. Also, what we found out later is converting JavaScript to TypeScript can be a breaking change, because products that are already using TypeScript and using JavaScript component that we ship would already have some typecasting for them. And sometimes those types wouldn't match. And introducing a TypeScript component would mean a breaking change for them. From now on, we decided to treat every TypeScript migration as a breaking change. With that aside, we started looking into unit tests. It goes without saying, testing utility and pure functions is easy with unit tests, so we just kept doing so. But then we also found out that we have some general rules and principles for our components. Things like we should always pass down valid HTML attributes to DOM, or allow setting underlying HTML tag with an as prop, merge CSS style and class name props, always pass the ref with forward ref, etc. So here, for example, I'm showing you a test for testing refs. So as you can see, we're just going through all the components and attaching a ref to it, and then checking if it was really attached. But here is the second part of this test, which we decided later. So we decided that we want the ref to always go to the root element of the component if it has some nesting. It helped us to not break those rules over time. The next thing we had was a lot of visual regressions while working on CSS or tweaking our component. And visual regressions in real life might look like this, when you have all of these things that should behave the same, but they look a little bit different. So we definitely wanted to avoid those. Normally folks use something like snapshot test because they're easy to set up. But if you look at the snapshot test that is failing, you're gonna see that, okay, we had a lead element and then we added a class name to it. But how much information actually does it tell you? Is it something that introduced a visual regression or not? And what we also found out that with automated snapshot tests, they were most of the time useless because we use CSS and JS or some generated IDs. So just by looking at these changes, we couldn't say if it was a visual one or not. We started looking for something that would show us the diff in a visual way, because visual diff is much better than just a snapshot diff. Some teams was using something like Puppeteer to automate this process and push images to GitHub. But we decided to go with Chromatic because it has a really good integration with Storybook, and also it has a great integration with GitHub PRs checks. So as you can see here, we have a failing test, UI test. And here's how it looks like. It shows you for this build, there is one unreviewed change, which has to be reviewed by engineer. But also one really cool feature is UI reviews, where we could involve our designers to actually approve changes that were intentional. While doing visual regression tests, we found some challenges. For example, how to ensure all possible states of a component are covered, or how to test pseudo states, how to test interactive components. So with all possible states, it's really hard to combine manually, because just take a look at this button. It can be in many possible states, but we couldn't tell if these are exhaustive, right? So we could see a lot of images of a button, but we couldn't tell if these are all of them. So now we're experimenting with Cartesian products, and here's a nice article explaining how it can be implemented. Also, there are packages that already implement this. And the idea here is simple. Just by combining different props in the different combinations, we could reveal all possible states of the button and render them. Also inspired by this article, I created this package. It's called WithSelector, that helps us testing a component pseudo states. So just adding WithSelector and using a selector that we use internally for different pseudo states of a component, we can render a button in different states like this. As you can see, this active, hover, and focus are states that normally are hidden from such automated tools. With visual regression test done, we started to think about how to improve interactivity in behavior tests. Before that, and actually still, we use the manual testing. And manual testing instructions oftentimes were going out of hand. And the second problem was that in order to test a PR manually, engineers would need to check out the latest branch, stash lock and changes, start Storybook and Playroom, follow instructions of the how to test, check out your working branch again, and then stash the changes, which was a long and tedious process. So we introduced deploy previews for every PR. So every time an engineer pushes the changes to GitHub, we generate Playroom and Storybook and deploy them. And if you're using Vercel or Netlify, you probably are already familiar with this feature, and it's really handy because now the only thing we need to do is open this link and follow instructions in the PR. But still, the question was how to ensure that manual testing instructions are complete. And this is where we started exploring model-based tests. Model-based tests generate tests automatically based on the state machine. So for example, here is a select component state machine that we have written. The select can be in idle state, and then if the item is set, it goes to item is set, otherwise it goes to item not set. And we resolve this automatically. Then essentially there are three states select can be in: item not set, item is set, and highlighting item. And now we could actually model the transitions between them. So if item is not set and I'm opening it, I'm going to highlight an item. And then I can select an item, or I can highlight another item, or I can actually just press escape and cancel. And then I select an item, I go to idle, and it resolves it to item is set. Sounds pretty simple, but to test this and having this kind of select, manually, it would require quite a lot of time. So we started generating those tests. So here is a test subject, our select and the state machine, and then we would use a script that would generate all these possible combinations. So now we can test the component not only using mouse, but also using keyboard, and we can automate all of this. Pretty sweet. For example, just for select, this script would generate 132 tests. Imagine testing this kind of thing manually. To generate this, we use Xstate and its test package. Also, one of the nice advantages of state machines we found was to use state machines to communicate user flows. And this is interesting because this is where designers and engineers would work much more closely. And those state machines could become a single source of truth, like a specification. We could just give those state machines to engineers and they could start using them to create a component. So here I have an example. One of the state machines we created for Data Range Picker. Together with designers, we started modeling those states and thinking about how the component should behave. And they started working on some Figma prototype and designing these states. So basically here in a date range, we have something that says select, and we can click on it. And then we go to the next state, select start date. There's a substate of start date empty. And you can see we are focusing here this input, and from here, now I can hover something on a calendar. And then I go and click it. And this moves me to the next state, end date empty. Okay, so now I have to enter the end date. I can again hover something on a calendar, click on this thing, and then I'm gonna apply. And you can see now I have a selected date range. Modeling the application or a component like this has a lot of benefits, because now we could actually extract information and see in what possible states a single date component can be. And by doing so, we could now do a visual regression test for those components in all possible states without guessing. Also, one of the advantages of this approach is now we could actually create components and visualize them on a single page in all possible states, even in complex ones. And then we would tweak a component and see the changes and possible breakages in one of the states, catching errors much earlier. All in all, this shortened the feedback loop by quite a lot. Accomplishing all of these testing strategies, we were able to move much faster. Now, imagine all of the test checks are passing and we're ready to merge our work. Now we have to release it and let everyone else know. So let's talk about release management. We heard loud and clearly that upgrading to the latest design system was taking too much time and would introduce a lot of issues in products. We definitely didn't want that. So we started thinking how to mitigate those. And we came up with two things. First, versioning, and second, automation. So let's talk about versioning first. We use semantic versioning, which you probably know as Semver. And normally, there are three numbers that represent major, minor, and patch version. But I actually like thinking about them as breaking, new, and fix. So every time we introduce a fix, we increase the last number. If we add a new feature or a new addition to the API, we increase the second number. And if we introduce a breaking change that requires something to change in the product to adopt this, we increase the first number. Breaking changes can be of a different form. Sometimes there's API changes. For example, we remove a prop or we deprecate a prop of a component. But sometimes we wanted also to rename components and deprecate all components. Also, we identified there are other breaking changes. So here, for example, is a discussion on GitHub if a CSS change that we are about to introduce by removing position relative should be breaking change. And the conversation went like, oh, okay, I actually don't think it should be breaking change because it's an internal implementation and engineers shouldn't rely on it. But then a colleague of mine told me, well, it can still lead to visual regression. And my thinking was that, okay, but then every CSS change is a breaking change. And actually, it can be treated as such. But obviously, we didn't want to release a breaking change every time we would touch a CSS. Is CSS change a breaking change? Well, the answer is obviously it depends. And the principle that we came up with to define if it's a breaking change or not is very simple. If developers in other products might need to change their code, it's a breaking change. But then we started to ask a question. So how do we find out if code needs to be changed? If we, for example, remove position relative from one of our components? Well, we found two ways to do so. First of all, visual regressions. And the second way is static analysis. So let me elaborate on first. Visual regressions of applications. And here is a simple idea. They tried and it actually worked. So we wanted to check out the main branch of the product that every product. So we have 3, so it would be 3 times. And then we would inject the current branch that we're working on of the design system into package.json and run npm install. And then we would run visual regression tests of their storybooks. And yes, it worked actually. And we used Chromatic for that as well. But we had a challenge where this method would only work if major versions of what they use and our design system would be compatible. So it didn't work when, for example, we would remove a component, then the whole storybook would fail. So it had some limitations, but it helped us catch some bugs. So here are the problems we faced. It only worked as major versions when the major versions would match. It was kind of hard to implement because of all of these dependencies, and we still were missing current development branches of those products. So now we're moving to monorepo and we hope to resolve all of these issues. So what about static analysis? And here's an example of the thing that we adopted. So every time we would ask ourselves, okay, can we remove a component, or what are actually the usages of the component? We would run it, and this thing would collect all of the usages across the products of this specific component. In this case, it's alert. And then it would show us what usages of the alert we have in different components. As you can see, we found 9 usages of an alert with different props. And that was very, very handy because now we could actually understand how the design system is used. But we went a little bit further. Because we found this so useful, we actually integrated into our style guide. So every time we would build a storybook, we would fetch this information and add to the storybook. So every time it is deployed, we have a snapshot of how the components are used currently. And an interesting thing, we could extract information where they're using. So now every time we're wondering how many times the button is used with onClick, we could just go into the code and actually check it out. And with this insight, we could answer questions like, what components should we move to TypeScript first? Because obviously we wanted to move most useful components. Or can we deprecate a component, right? Should we change the default value of this prop? Also helped us quite a lot identifying what should be the default. What's the risk of changing a component? If there are a lot of usages, the risk is high. If there's just a couple of usages, well, okay, we're just gonna test it manually. Or what is the adoption rate of a design system? So to recap, we use semantic versioning to communicate the changes to external teams. The breaking changes are generally okay, and they should be treated as such. We use visual regression and static analysis to identify when we should do a breaking change. Let's talk about the second part, automation of the release management. And by automation, I don't mean things like CI and running things in the background. What I mean is something like automatic migrations. So we still didn't want engineers to do migrations manually and mitigate the cost of the breaking change. So here's an example. We wanted to do a new input, but we already had an input. So how do we introduce a new input while having an old one and being used quite a lot in our products? So we looked at usages, and there are quite a lot of them. And we would do something like this. So we would delete the previous input and create a new one and replace it. And then we would create a new release saying it's breaking change, be aware, input is a new one, and you have to upgrade. And then in product, they would upgrade to the latest version, and they would need to manually search and replace all usages of input even before they could start working on a product features. And it would cost a lot of time. And that's where it came from. Upgrade takes days, if not weeks, lots of defects after, because it's really hard to do this manual tests after this kind of upgrade. We decided to change this process. So now in design system, instead of just removing a component, we first rename it to a deprecated input. So an input becomes a deprecated input. Then we create a new input component, and then we create a breaking change and then write a code mode. I'm going to elaborate on this in a second. And then in product, they upgrade to the latest version, and they run the code mode, which is an automatic migration script that renames all inputs that they have to deprecated inputs. And this would be just one PR that they are ready to push to GitHub in a few minutes. Then someone just reuses it just to make sure they didn't break anything. The tests are running and then they're merging it. So in a few minutes, they're up and running on a new version. And then they can start incrementally adopting a new input because the old one is deprecated input. So a breaking change becomes an incremental one. So what are code mods? These are code refactorings based on ASTs, abstract syntax trees. So here is an example of some JSX code. And this site called AST Explorer, go check it out. And you can see how I am hovering here. I can see things like import declaration. And where's my statements expression? And I can see a JSX element. And here's a script. And this script looks for all identifiers and reverses them as characters in them. So what we can see as a result here is import not top from button. So it's basically just reversed the names of all of those identifiers. But you can see how it found both imports and usages of this button component. And this is crucial for us. And here is a deprecated code mode algorithm that we use. So basically replace import statements first, then replace call expression, and then replace JSX expressions. So we had different cases with dot notation, without dot notation. So we had to take care of those. But after we identified all of those kind of usages and wrote tests on them, it was an easy job to do. But then I started to see questions like, okay, now we deprecated something and it's working well. Everyone is happy, but we still have to maintain two components. How long to maintain deprecated components? Or what about the deprecation of probes? Or more complex refactorings? We decided to do the same as before. We would check out usages, and until there are some usages of this component, we would keep maintaining it. But of course, we were also communicating that this one is deprecated and has to be replaced over time. But we didn't want to push a pressure on our product teams because they were working for our customers, and we are a maintenance team basically. So that's the rule. Until there are usages, we don't deprecate. It is important to create and document your processes so everyone is on the same page. I can't stress enough how important it is to invest in infrastructure and developer experience. Things like automatic migrations and understanding how your code base is being used in other products saved us hours, if not hundreds of hours of time, and prevented a lot of bugs and errors. And make decisions based on your insights, not on your feelings, because sometimes you might be thinking, oh, yeah, I think this component is not being really used, but then it can be one of the crucial parts in the product and you breaking customers' flow. Automate everything you can and be empathic. To recap, design systems are so much more than just a component library. And oftentimes people think, when they say it's a design system, they're referring to a component library. But as I showed today, it's not just that. There are principles, there are rules, there are processes, and there are teams working together. And all of this define an efficient design system. Thanks, that was it for me. I hope it was helpful and interesting. Also, there is going to be a Q&A today. So if you have any questions, please join the Q&A and ask me any question. You can also follow me on Twitter. These are two handles, my personal handle and the handle where I post about stuff about design systems. I collected links and credits that I was mentioning during my talk here on this page. I'm also going to publish the slides and transcript of those slides on my website, componentdriven.dev. So don't hesitate to go there and check it out. Also, I'm offering workshops about how to build component-driven design systems and resilient component libraries using React. So I hope to see you on one of them. And I wish you a pleasant day. Bye.
Thanks a lot, Andy, for the session. The session was really good and interesting, and we learned a lot from that. So I have a question for you, Andrew. Hi. So I have a question for you, Andrew. Like as a developer, the documentation plays a really important role for us, right? The documentation of anything, of design system or any library or something. So it's really hard for us sometimes to know whether this documentation is updated or not. Like, so how to keep that on track? Like, how to analyze the things and because a lot of documentations are not updated also. So as a developer, sometimes it's hard to use some components of library. So I just want if you can comment on this, like how to overcome.
Yeah, it's a good question. Yeah. So I think first of all, what I would say in this case is it's about the mindset. So what we were also struggling is this problem. Like, yeah, okay, we would have some kind of documentation, right? Because we had a storybook, so something would already be there, but it would be just automatically generated documentation stuff like, okay, prop types to be dumped into the so storybook. So developers were looking at the storybook and they were like, oh, okay, there are 100 props. Okay, good. Well, you can find this information just by looking at a component in your source code. So it wasn't very helpful, right? Then the second part was like, okay, good real world examples. So this is also, so we had a lot of kind of example stories, right? But they weren't really real world. So this is also what I encourage people, people who work on design system, be empathic about how your component is going to be used, right? So if you see some usages of a component in the application, maybe that could be a good example for everyone else. So you could just make a story out of it and share it with everyone how it's supposed to be used. And the third thing that what helped us was a more structural approach to generally how we deal with the documentation, right? So we created a template. So every time we create a new component, we already have a template that goes like, okay, here's the problem definition, here's the solution, here are when to use, when not to use, stuff like that, right? We also have an embed Figma frame that shows the anatomy of a component because designers would design it in Figma and they would like to show what parts of the component, how we call them. That already would be also up to date all the time because it's embed iframe, right? And they would have like these examples. So I think it's also important to mention that it should be a team effort. So it shouldn't be like, hey, it's design system responsibility. Yes, it is, but the design system acts as a cross-functional team in this regard as well, right? So there are multiple roles in the design system team. So there are designers working with us close together, engineers doing React. We have a special build and release team who takes care of like CI and stuff because there are just so many things we have to take care of. But still, we have like this area that's called design system where we all work together and interact together. So I think it all takes kind of shared responsibility as well. Yeah. And the most important thing to answer your question, I think, is to treat documentation as a product, right? So design system isn't just your component, it's just your code that you're shipping. Treat documentation as a product. This is what your customers engineers in other teams or designers in other teams going to be looking at, right? That's your product. This is how you represent yourself. So you should be proud of that.
Yeah. Thank you for answering the question. We have a few more questions from the audience. One question is, what is the tool for generating of usage React components? So
so to track the usages, we started with, I can't actually remember the name. That was one tool. It's funny because a few years ago I tried to write similar tool. So I was interested in this syntax, abstract syntax trees, and I was like digging into that. And I tried to write a tool, but I didn't finish. And then a year later, I saw an open source project came out doing exactly that. So I was like, oh, cool, I don't have to do it anymore. So I can't remember exactly the name of that project, but there is the newer one, which I think is a superior one. It's called React Scanner. I also gonna share links to slides. I actually shared already in the chat, but I can repeat. In the end, there is probably one of the most like finished closing slides. You can find all the links to all those things I'm mentioning. So yes, we use, but then in the end, we actually wrote something our own, because none of those tools will accommodate to our usages, but it's not that complicated. So check out React Scanner. It's probably the most versatile open source project you can start with, but then just explore what you can do and maybe build something on top of that.
Yeah, I hope this clears the question. Okay, the last question which is there is, can you explain CodeMod a bit? Where can I refer the existing CodeMod that you guys use internally? I guess he wants to say that you guys use internally, right?
Yeah. So the CodeMods part is, so the idea is simple. So instead of trying to do search and replace on strings, right? So if you look at code, it's just it's a lot of text. But essentially, what computer does with your code, it builds, then it reads the code, right? It creates this. It creates like a graph of the whole thing. So there are expressions that. All in all, I'm trying to explain quite a complex thing in simple words, and I think I suck at it. So the essential part here is that there is an abstract syntax tree. This is also how basically a computer would see your code before it goes to the binary, right? And by parsing the code and looking at an abstract syntax tree, not strings, you are able to identify relationships between things like, so if you define something as a variable, right, it's going to be an identifier. So there is a specific type of this tree node that is then going to be referenced somewhere. So if you want to rename that, then this is pretty much how IDE work, right? So if you start renaming a variable in somewhere in your code, you want that all usages of this variable are going to be renamed. And this is pretty much what CodeMods is doing, just not in the IDE. It's a script that runs, it goes through all of your files in the project. So you say all TS6 file or G6 files, right? And what we do in our case, we want to rename something that is input to deprecated input. So we created one CodeMod that we just pass a component name and it adds deprecated. And then we're searching, okay, there is an import statement. So let's see if inside the import statement, there is an input. If they find it, we're going to convert it to deprecated input. But we do this across all the whole code base, right? And we just automate the whole process. So you can, there are good talks about this as well. And the whole tooling came from, I think, also from the Facebook React team. So they had the problem of upgrading. So I think Facebook actually shipped CodeMods as well, and Jest ships CodeMods. So yeah, I can share a link to the tool that you're using. But actually, yeah, I know I'm mentioning this in my slides as well, so you can find it in the end of my slides. Yeah. I hope that answers the question. But I mean, it's a complex topic, but generally, we just do refactoring at scale.
So I guess our crowd is really enthusiastic. They're asking a lot of questions. They have a lot of queries to be answered for you. So one question again I have got from the audience: what tool do you use for the static analysis? Like for the static analysis, what do you use? What tool do you use for the static analysis?
I just read about the shaking. I think it was me and not the table. So it is on a table, but it's like a standing desk, and I was putting my hands on it. So I'm just gonna lean backwards so it doesn't shake. Sorry for causing that. So the static analysis, it's same thing. So we rely on the same idea. So we work with abstract syntax trees, right? So there are different parsers. So think about if you're using React, you probably also use Babel, and Babel is the parser that works with abstract syntax trees. So it enhances your so there are Babel are just scripts that say, okay, if you see this syntax, convert it to that syntax, right? And they used I think for our static analysis, we even use TypeScript parser, or we use Babel. I don't know exactly right now because we constantly changing those bits, but it doesn't matter because as long as you use the parser that parses your source code, right? So if you're using TypeScript, it needs to be TypeScript compatible, but we also have Flow, so I think the requirements were quite different back then. So then you can understand what components you're using, right? So, and this is the technique. So basically just parsing the source code of the product where the design system is being used, we can understand what components are being used, and we can gather all of this information and then present in a nice table. That's it.
So I hope this answered the question, and you can always connect with Andre in LinkedIn. And
no, please don't use LinkedIn. Use Twitter. So if you have any questions, you can reach out to me on Twitter. Here's my handle. Also, let me also share the link to slides. Just one sec.
Sure.
So here's this link. There are 2 links in the bottom, right? So one is for recording and transcript. So if you find my speech not very comprehensive, you can read the transcript. That's one of the advantages of the pre-record session. And the second link is the link to the slides. So you can also go through slides on a full race. So yeah.
Cool. It's really nice of you, Andrew.
Thanks for having me, and have a nice day. And I hope you enjoyed it. Bye.
Thank you. Bye. Thank you.